Assalamualaikum and welcome everyone. My name is Mohamad Hanif bin Saad and I'm going to present the slide for our project. This is basically the work of my students, Mr. Khairul Hafizi and Mr. Abdul Hakim Juhari, along with my colleagues, Mr. Khairul, Azhar, Sulaiman, and also Professor Dr. Aini Hussain. We are from the Faculty of Engineering and Built Environment, University Kebangsaan Malaysia, and also from the Institute of IR 4.0, University Kebangsaan Malaysia. So the title of my presentation is a secure cloud-enabled indoor hydroponic system via ThingsSentral IOT platform. So the motivation of doing our project is the presentation outline. For the outline for this particular presentation is arranged like this. I will talk on the motivation of developing the system that we mentioned before. We will look at the design of the system architecture, and we look at some early results and future works that will be done accordingly, and also some of the references that we utilize in this research. Okay, as you know, the world population is growing at almost exponential growth. So in 1750, if you look at this diagram here, if you look at this figure here, in 1750 there are about 1 billion people all over the world, but by the year 2000 we have about 6 billion people on this planet, and it is expected that by the year 2100 we will have about 10 billion people living on the face of the earth. And previously, the size of the arable land in the world for the past 40 years has been decreasing, and even if it is not decreased, the size of land which can be planted on the face of the earth is a constant. It cannot be increased significantly. So some of the solution that people has done is to grow those food, or to grow the plant indoor, utilizing industrial indoor farming like shown in this slide here. But even that does not produce adequate food for everyone, because we always need more food than that is currently available. So one of the solutions that we can see is that to grow our own food inside our house. So we have an indoor farming module that can be put inside your house, and this indoor farming module can be used to produce food for the family. Okay, there are a lot of modules like this available on the market, and a lot of people are going into this business nowadays, and which is a good opportunity for everyone. And for our research group, we would like to contribute as well towards developing something like this. Okay, so if you have an indoor farming module in your house, then hopefully with adequate technology and method, you can grow your own food, so that you can utilize the food that is grown inside your house. Remember, nowadays not every house nowadays has a place to has a ground to plant vegetables and so of sort. If you go to Kuala Lumpur nowadays, most of the houses are apartments and flats, whereby to plant the crops, we have to do it inside the house. So let's say we have our own indoor hydroponic module that can be used to provide food for the family. Then if we want to increase the yield of the system, we can always automate it, use the help of sensors and controllers, and in particular the Internet of Things technology, to help automate the process of planting and growing the food, so that we can have optimal yield from each of the food that we grow inside our house. For instance, we can use microcontrollers to make sure that the plant has adequate lighting, or the plant has adequate water supply, or the plant has a suitable temperature and humidity. Now, if it would be better if those indoor hydroponic unit can be used to serve a number of houses, which means that if we use IoT and we can increase the yield, then we can share our crop with other people, with other houses. Now if we live in an apartment especially, this is very crucial or very important. You don't have to go out to the shop to buy vegetables if, let's say, one of your neighbor grows them inside their house using the hydroponic system that we mentioned just now. Now, if inside an apartment we have multiple people growing food using the indoor farming module that we mentioned just now, we hope that multiple houses can benefit from that. Okay, you can see on this picture there are 3 houses whereby the housewife is cooking, and there are 2 houses whereby there are people who are planting crops and vegetables inside their house. But managing this is quite difficult because you have to know when the crop is available. You have to know which house has which crop that it requires. For instance, if I'm cooking rendang, I might want to have serai. So if I'm cooking some, let's say, spinach, I need to know which house has grown spinach so that I can buy from them, for instance, so I can request from them. So we need to have a centralized system which can help us to automate the process of growing and also automate the process of distributing. So the best way to do that is to put a centralized system on the cloud. So we put a centralized system on the cloud, the growers will be connected to the cloud, and the system can be controlled by the cloud to ensure optimal yield, and the user can be connected to the cloud and be notified which house has which crops that you want to use or you want to cook. This is a very optimal solution. So this is an optimal automated solution whereby the supply of the food is matched with the requirement of the food, and also utilizing and growing the food is automated by a centralized control system. However, this kind of arrangement always have one big problem. There are always bad people that try to hack into the system and take control of the equipment for this particular fellow. Say for instance, if he's growing the food inside apartment A, this hacker can get into the system and maybe he can disturb the operation of the system here. In fact, he can also disturb the information flow from the house to the cloud. Means that rather than sending the cloud telling that now we have a serai or we have spinach available, he might replace it with other things, other nefarious things inside, nefarious information, bad information. So in order for us to have a secure system like this, we need to introduce some way to secure our cloud and the connection between the hydroponic system and our cloud. So we propose our system, which is called a secure cloud-enabled indoor hydroponic system via ThingsSentral IOT platform. What we want to do, we want to develop a secure cloud-enabled indoor hydroponic system, and that system is going to develop using our ThingsSentral IOT platform. Right, this is the overall architecture of our system. This is our cloud, and this cloud is developed using an IoT platform called ThingsSentral. ThingsSentral is an IoT platform which was developed by our research group in University Kebangsaan Malaysia. It's a general purpose IoT development platform. You can utilize it to develop any IoT system that is suitable to the platform. Okay, so the platform collects data from gateways and can be used to execute commands from other gateways, from other actuators. So in this particular case, looking at solving the connected connected indoor hydroponic system, we are going to utilize ThingsSentral to develop the platform. So our indoor hydroponics module is going to be controlled using using a Node MCU microcontroller. Node MCU, sorry, not Arduino, but Node MCU microcontroller. So the Node MCU microcontroller is connected to OLED screen, water pump, water motor pump, pH and EC sensor, light sensitivity sensor, voltage and current sensor, and also temperature and humidity sensor. So this is the infrastructure of our system. So the normal thing is that the controller will pass data to the cloud, and then the cloud will store the data and do some processing. But we also introduce an authentication mechanism through smartphone. An authentication mechanism through smartphone, other than the authentication between the indoor hydroponics modules controller, we introduce a second authentication used through smartphone. We believe that there is a lot of IoT development platform available on the market, but most of them are not equipped with external or extra authentication method. So most of them, the authentication is between the controller to the cloud through the use of access keys and passwords. But we introduce a second authentication mechanism through user authentication via smartphone. So we call so this basically follows the concept of two-factor authentication. The first factor is at the microcontroller level, and the second factor of authentication by the user or the owner of the system. So the secure cloud-enabled indoor hydroponic system is basically split into two major development: the integration of indoor hydroponic system with Node MCUs and sensors and transmit them to the ThingsSentral IOT platform, and a two-factor authentication method aims to strengthen the transmission and receival of the data while using the internet as a communication medium. These are the electronic component that we use. We use the Node MCE microcontroller development board. We also use the pH sensor. We use the current and voltage sensor. We use a digital temperature and humidity sensor, and we also use the soil humidity sensor as well. So this is the design of the hydroponics mechanical module design. We are still at the early stage of the development. There are some modules that we are still in development stage, but we have designed the hydroponics module as shown here. It should have a maximum capacity of putting about 120 plants, and the dimension is given at this dimension here. So this is a close-up of the hydroponics system, and on the second part is the secure operation authentication procedure that we introduce into the system. When the Node MCE microcontroller start the program to start the system, it will request for project and gateway access. So each node is a gateway, which means that each hydroponic planting unit has its own gateway. When it sends for the authentication process, the ThingsSentral cloud will analyze it, and if the value or the access code is given is correct, then it will initiate smartphone notification and a second authentication procedure, which must be done by the user through the handphone. If both of these are correct, then the hydroponic farming system will start to operate, and we'll execute the rest of the operations. We intend to make an experimental version of this project as a public project which you can view online. Thank you.